another draft physics video presentation. Still two slit stuff, I think. Some Feynman video, and just go over some of the basics again. And making the argument that I really shouldn't have to make in this way. There should be lots of physics-minded people, truth seekers and truth defenders, willing to provide some sort of feedback, either positive or negative, and yet there hasn't been any of that. And kind of strange that scientists are so disinterested. But anyway, yeah, strange. I'd argue it's strange. Anyway, so I did update the website a little bit, and I did put a page on regarding the offer of $1,700, and so I'll just read that briefly. I am offering any science-related YouTube channel with more than 100,000 subscribers a payment of $1,700 to play, and if they wish, critique this video on their channel. And the video linked is the what is a photon video that you can find in the subject playlist. Anyway, if you can convince the 17-minute video, I guess I should put that in there. If you can convince a qualifying channel to play the video for less money, I will pay you the difference. So you can make some money if you could, snooker, some channel into agreeing to to play the 17 minutes of two-slit analysis. This, like I said, this really shouldn't have to be done. I mean, you could argue if it's good physics, if I'm correct and I'm offering some sort of insight into the fact that there may be a simple mechanical explanation for the two-slit experiment, that it's not an inconceivable thing that's impossible to describe, and all of that, the channel would be doing the world a favor, so to speak, all of science some sort of favor in terms of just pointing out that this is an argument that needs to be dealt with, that they have a very complex theory based on a bunch of very extraordinary claims about behavior of simple objects, and if that claim is to be maintained, they have to debunk, and they have to point out how this cannot be the truth, a viable truth, because that's the obligation of when you're making claims, is you have to show not only that your client is perhaps not guilty, but that somebody else is. It always helps to do both things. Prove the counter theory impossible or improbable or unlikely or in some way less desirable. And you think they'd want to do that. And if I'm wrong, they still win, So if I'm right, they're doing the world a favor. It won't look good that I have to pay them $1,700 to do that. But anyway, the fact is that they'll be the ones who did the right thing instead of the wrong thing, which is ignore their obligation to defend their science when it's been reasonably and fairly challenged. And I've reasonably and fairly challenged it. All right, anyway. So, to Feynman we go. Hi-ho, hi-ho. I'll probably have to make an adjustment in this screen here. It's probably in the wrong place now. So I will just slide that over. And that should be adequate to the purpose. Alright, so we left off wherever. And so I'm just going to continue at this location where he's doing an analysis in terms of electrons. He says photons do the same thing. He describes the electron experiment as being, it's a tungsten plate and blah, blah, blah. And we know that if you hit electrons into tungsten, you're going to create X-rays. But whatever. The whole thing doesn't have really anything to do with the truth, because the electron experiment isn't this simple. It's much more complicated. But in some respects, there are parallel facts of life that have to be dealt with in terms of describing what actually happens when you actually do the experiment. And Richard fails to get those correct. So I'll take a little pause in case I have to use the blackboard, I'll clean it. Courtesy. Alright, should be back. So let's remember, Richard Feynman did get the Nobel Prize essentially for his analysis of this experiment. I mean, his shortcut in terms of doing the probability math, and the probability math based on, this kind of effect. Yeah, and just pointing that out, that this analysis is really bad. And, there's something wrong with the fundamental physics if it rewards people highly for pretty sloppy analysis.
We say maybe we can analyze this by thinking that the electrons come through this hole or through the other. So we can close one hole and measure how many come through hole number one, and we get that curve.
All right, now we know we don't get that curve, so that's just so deceptive in the sense that the curves aren't in different locations. So again, that one is so obvious, and this is true for photons or electrons or any small object you're going to be dealing with. The whole idea of projecting it on a screen is for the purpose of enlarging the pattern, because it's a small pattern in the first place. But it also shows the distinction between the stuff that actually is being changed in its direction and the stuff that doesn't change in its direction. The stuff that you can understand still travels a straight line. So, I'll re-illustrate the point. I hope that works. Seems to be a little low and very dark for whatever reason. Let's see. How could it be that low? How could the angle be that far off? I haven't changed anything. Really, it's just the resolution of the camera. So, I mean, it's just, like I said, little technical difficulties with OBS in terms of changing resolution on you. See, it really shouldn't be that low. It really shouldn't. Camera, stay up higher, please. Alright, so the idea is you have these slits. And so he's arguing that you cover one of the slits and you get a pattern over here. And you cover the other slit and you get a pattern over here. That's not happening. The slits are just a millimeter apart, less than a millimeter apart. The projection is fairly large. You could say it's 1 foot, that you're going to view the fat pattern at. The substance of it will exist within that 1 foot. But you're going to, essentially the pattern's being projected, and this stuff, everything that happens, between this 1 millimeter is still just 1 millimeter over on this side. It's still just inside 1 tiny millimeter. It's a tiny fraction of the pattern that's taking place inside. That's not diffracting out, that's diffracting in. Okay, so the part that's, anything that goes in is going into a tiny 1 millimeter spot, and everything going out is going out to a 1 foot spot. So you can understand these two patterns are distinctly different. Everything going in is going into a tiny space. Everything going out is going out to a wide space, very large space. And these two patterns will be right on top of each other. You won't really be able to see the difference. This one will create a pattern. Now we know it doesn't just do this anyway. We know it just doesn't do a blob like this. It does a pattern. It does even at its worst. Okay, even when you try to make it as wide as possible by narrowing the slits, you're still going to have some expectation that you're going to get a pattern that has, character to it. You're going to be able to see these other fringes quite well. And these two patterns, you cover one slit, you see that. You cover the other slit and you see this. I mean, it's going to be, indistinguishably the same exact pattern you're going to see. That would be the expectation. Now we know we don't see that. Okay, that's not what happens. Instead, we get a pattern that has this. Okay, little bars show up. All right, now this big pattern could still be there, but you don't see the big pattern because you're distracted by this little pattern. So the big pattern is hidden in a sense, and all you really see is, oh, there's a darker spot here, and there's a darker spot here, and you know, that kind of thing. And these little bands are a little brighter than these bands, but it's really just the same thing. It's that, you know, you just have to understand, well, why would that happen? And the simple explanation is because you're dealing with more than two sources. Okay, so, and you're dealing with more than one photon is the key to it. More than one had to go in to create the pattern, and so it's you're just not doing the two-wave thing. You're not doing this idea that you're not adding, by adding more sources, you're adding a significant amount of more light, not a little bit. So when you only have one source, you have just whatever these two lines can create. And obviously when you connect another source, you're connecting two more vectors. And so it's 4 times the, you know, the 1 plus 1, okay, in this case is going to equal 4, because the ones are really two sources. Yeah, that really should be enough for anybody who knows anything about the subject to just point out that's why the pattern changes. You don't get this pattern plus this pattern. You're getting two sources plus two new sources, and so you're really getting 4 times the light, because you have 4 times the opportunity to reconstruct a photon. So it's just not, the expectation that it's just a photon plus a photon is incorrect, because it doesn't appreciate why the photons are being, how the photons are being created. I think I could have said that just better, but we'll have to live with that.
Or we can close this hole and measure how many come through hole number 2, and we get that curve.
So again, we don't do that. That doesn't happen. There's no expectation that would happen. It's perfectly understood that those two patterns will end up right on top of each other. Just a tiny millimeter of distance. Just tiny.
These two added together is not this, and so this...
Right. The two added together aren't that. The two patterns don't just superimpose over each other, because the two patterns are creating two new opportunities to reconstruct a photon. Some piece of technology failing here. Hold on a second. Yeah. Continuing.
This is not the same as N1 plus N2, and it does show interference. It shows interference.
So it shows a pattern, and again, the pattern is the simplest pattern you could make in the universe, basically on, off, but the double slit pattern does have that little extra piece in there where it goes off, off, then on, off, and then off again. So they don't even, you know, Feynman's not even acknowledging the fact that the double slit pattern has this fundamental difference, and that the strangeness of it is that it does appear that there's an envelope of the single slit controlling a double slit pattern, but really it's just two equal slits, and there's a difference when you combine the two. You can almost make it into a genetic argument, or some other way you can understand that even though they're just single individuals, the mixture isn't going to be exactly the same as any one of the individuals.
And in fact, the mathematics is given by this funny formula that the probability of arrival is the square of an amplitude, which itself is the sum of two pieces.
So that's his contribution to science, is merely this understanding that we can do probability math by just squaring amplitudes. But it's, the probability is because there has to be more than one photon at a time in the system, and that's the part they never really thought about or figured out. The reason why the patterns are different is because there's really 4 photons being broken at any one moment, and you're just putting the pieces back together at the surface. Some yes and some no.
Now the question is, how can that come about? That when they go through hole 1, they would be distributed this way. When they go through hole 2, they would be distributed that way. How can it be that when both holes are open, you don't get the sum of the two?
Right. Well, you do get the sum of the two in the sense that that would be your expectation, that the sum of the two would be on top of each other, so they would look like the same pattern. They would be so close to being identically in the same place. So the two patterns would look like a brighter version of the original single slits. But those single slits, again, have to be understood as being 2 sources. So, you have to do the right math. You have to add 2 plus 2, not 1 plus 1.
Instance. If I hold the detector at this point here, I get practically nothing.
All right, so now he's doing the detector. So he's saying I get practically nothing, which is, his assumption that the pattern is in this weird position, which it's not. Okay, and so obviously, if he held the detector right across from one of the slits, he wouldn't get practically nothing.
If I close one of the holes, I get plenty.
So again, we know those two patterns are going to be right on top of each other. So whatever you get when you have one hole closed or the other hole closed would be exactly the same. So even if the pattern didn't do the funky thing where you're adding the sources, you wouldn't change the fact that when you close one hole, it will look the same as if you close the other hole, because the two patterns are going to be right on top of each other. So it would look essentially the same. The detector wouldn't measure a huge amount of difference. It would say, yes, one slit looks just like the other slit when they're opened individually. And where things change is where you add the 4 times, where you square the amount of possible combinations that will make a successful photon by adding 2 sources plus 2 sources.
If I close the other hole, I get something. If I leave both holes open, I get nothing.
So that's the one they never prove. They have no experiment demonstrating. There's no hope that could make sense or be correct. So they're asserting it as a fact. So this is the mystery that has to be solved, is this fake, phony mystery that doesn't exist as a real fact. So you're accepting a false notion of an outcome that just isn't correct. It's not based on science or evidence. It's based on an assumption, based on a wrong, a misplaced drawing. So there is no, it was bright and then I opened a second slit and it got dark. There's no evidence that happens.
If I let them go through both holes, they don't come anymore. Or take the point in the center. You can show that that's higher than the sum than it was in the other case, than the sum of these two. I get more here when both holes are open than I would get with either one of the two closed.
Well, that just makes sense. So I get more open when they're both open than I would if both of them were closed. I mean, of course you do. I mean, of course you get more than any single slit can produce. So, I mean, I could play that again, but I mean, that was just, yeah.
If I leave both holes open, I get nothing. If I let them go through both holes, they don't come anymore. Or take the...
So again, it doesn't happen. No place that, if you open one slit and then you add the second slit, no place gets darker. There's no evidence that happens.
Point in the center. You can show that that's higher than the sum than it was in the other case, than the sum of these two.
Right. So, I mean, the sum of those two, this is how bad this is, right? Because he really is thinking that the midpoint, this 1 millimeter of space projected on the board, is somehow dark, because the two humps are somehow far apart from each other, and there's a nothing there, and it's just wrong. It's just so wrong, because that's not what the patterns are doing. I mean, it's just fundamentally and catastrophically bad as an analysis of the experiment. It's just so fundamentally flawed. And this is supposed to be a person who's an expert on this subject. a Nobel Prize winner on this subject.
I get more here when both holes are open than I would get with either one of the two closed. Now
So he's saying I get more with any one of the open than two closed. Okay, again, he's saying the same thing, which obviously you get more light when you have two slits open, and it turns out probabilistically that you get 4 times as much light with two slits than you would get with either one of the slits.
You might think that if you were clever enough, you could argue that they have some way of going around through the holes back and forth, and they do something complicated, or it splits in half and goes through the two holes.
So that's his way of saying we've analyzed it all possible ways, and there's no other explanation but woo. And no, they really haven't. They did it as trivial as he has just done it. I mean, they spent maybe 3 minutes thinking about possibilities. And that's it. Because if you do think about it a little bit, you start to realize, well, you know, especially if you say, what if the surfaces have something to do with it? Well, then you automatically know that you have 4 point sources, and that it's a lot more complicated than, and you don't have to do this goes in here and goes out there and all this other stuff. And then you also realize that these photons are something that's a pattern, and that all you're really doing is remaking the pattern. And you might not be making it, the new pattern might not be, it might be made out of parts of photons, not the original photons.
And so forth in order to explain this phenomenon. Nobody, however, has succeeded to get an explanation of this that's satisfactory, because...
Yes, except I have. And yeah, so I don't know. I mean, I have to admit that I haven't seen anybody else explain it rationally. Okay, so I haven't seen any other person produce a video that in any way explains the double slit experiment in a rational manner with any other mechanism but some wooey, crazy theory about all kinds of stuff going in all kinds of wacky directions. So I haven't seen that done. So I guess he's correct that nobody maybe had offered a rational experiment or a sensible one or a simple one, but now I have. So that argument's not any good anymore.
The mathematics in the end is so very simple.
Yes, exactly. The pattern is simple. It's on-off pattern. And the only flaw in the analysis is you have to accept that photons are an event that happens over a period of time. A photon doesn't go to the slit and just, okay, I'm in the slit. No, a piece of it is in the slit at any one time, and then another piece is in the slit at a time, and then another piece of it. A photon, it has a length, and it takes time for it to get through, and different pieces of it go different places, and that explanation works.
Very simple.
All you're doing is reconstructing the frequency and the phase. That's it. And you have a 50-50 chance of doing that by rational odds. And the pattern is pretty much 50-50.
Summarize then by saying that electrons arrive in lumps, like pot.
Right, so we already did this part, but I mean, again, I'll argue they only arrive in lumps because we have lump detectors. So the fact is that our detector requires the photon to bring its frequency, to bring its length. It has to have its frequency and it has to have a certain length, or our detectors can't deal with it. Now the photodetector gives us some indication that there might be photons that we can't see, because we can turn its sensitivity up and it starts counting photons that we can't recognize as photons. None of our other detectors will see them. Our eyes won't see them. A photodiode won't see them. Other things won't see them because they're not complete enough photons, and the photodetector is more sensitive and can see photons that are smaller. I could make the simple argument: bits of frequency that are less distinct. And so just as it's conceivable we could make a radio receiver that doesn't need as much signal to detect a radio signal, it's conceivable we can detect these broken photons.
But the probability of arrival of these lumps is determined like the intensity of waves would be. And it is in this sense that...
Well, again, the intensity is just based on the fact of whether or not, again, you put phase back together, and that argument could go back again to the any two sources. So if you want to make a wave comparison, you can understand that all this is really about is phase and out of phase. And if we don't have a detector that can detect two things that have the same frequency but are out of phase, and that's a fact, that our radio receivers can't deal with that unless we make them directional. It's just a fact that jamming's a real thing, and that you can jam, so to speak, our eyes and a surface.
The electron behaves, as you might say, sometimes like a particle and sometimes like a wave. It behaves in these two different ways at the same time.
Alright, it's not really behaving like that, it's just leaving evidence like that, right? So the behavior isn't this, because we're not seeing the behavior, we're not watching its behavior, we're watching what it drops as an event, what it drops as an outcome, what it dumps. Okay, so we're looking at photon scat and electron scat, and we're trying to analyze what the photon's been up to, but we're not watching the photon. So again, it's so it has evidence, it leaves behind, okay, and something that could give us that impression. But like I said, logic, you can do some of that and recognize that you're being fooled, because it really isn't doing anything wavy. It doesn't work. Waves don't work. You can't rationally draw them and make the pattern.
And that's all there is to say.
Make the right pattern.
I give a mathematical description to figure out the probability of arrival of electrons under any circumstances and so on, and that would, in principle, be the end of the lecture, except that there are a number of...
So again, they don't predict anything, they just predict generality, right? So they don't predict anything for any single photon, and again, single photons in the experiment won't work. And that sort of was verified by Veritasium. He attempted the experiment with a modern device, a $5,000 little piece of equipment. And the evidence is he couldn't get it to work unless he cranked the photo detector all the way up. And by doing that, he sort of guaranteed that he has more than one photon at a time in the experiment. And so they really can't do it. They can't really, and there's no expectation that we have any control over the single photon at a time thing, when they're not even recognizing that they might be completely wrong about how photons are created in the first place. And they might be, just as we receive them with clump detectors, the fact is photons are probably created in clumps, more than one at a time. And so you'll have a burst of photons, but you can never send a single photon. You can never create a piece of lightning, let's say, in the atmosphere and have the expectation that the lightning would only create one photon. The same might be true for how photons are created, that they are created by an electrical event, and the electrical event can't just produce one photon at a time.
Subtleties involved in the fact that nature works this way. There's a number of peculiar things. And I would like to discuss those peculiarities because they may not be self-evident at this point. So to discuss the subtleties, we begin by discussing a proposition which we would have thought to use since these things are lumps. Since what comes is always one complete
All right, yeah, I don't think so. So again, this lump argument just has to do with the fact that that's all we can detect is lumps. We have a bunch of lump or clump detectors. We don't have discrete pieces of energy detector.
An electron. One complete lump, one complete electron. It's obvious that it's reasonable.
See, it's obvious that it's reasonable. Again, we detect photons by detecting an electrical signal. That's how our brain works. That's how everything that detects a photon, it detects it by detecting a cascade of electricity. And in the photodetector case, again, that's one where the photomultiplier, the uniqueness of it is that you can make it insanely sensitive. And when you do that, though, the problem is that it starts seeing photons everywhere, which would almost be like saying it starts to see gravity. It starts to see the fact that photons are made out of gravity at a frequency.
that either an electron arrives, or goes, let's say, that either an electron goes through hole number 1, or it goes through hole number 2. That seems like...
Right. So the whole point would be is that it's a frequency, a pattern in space, and that at every surface there has to be a pattern going by the surface for the particle model to work. So any experiment that could prove that there was no energy at this surface, and there was no energy at this other surface, and there was no energy at the other surface, and yet it still creates the correct pattern, that would be what they need, and they don't have that. So they've just made an assumption that there's only one photon here, there's only one photon here, and one photon here, and that photon somehow travels to the target. And all you have to do is say, well, if I understand that photons are composite objects, I can, and they're simple, they're just made of bits of momentum at a frequency, that I could change where the bits are going, and I can still be able to recreate the frequency, and that's all I really need to have a photon, is bits at a frequency. So a piece that comes from one surface and a piece that comes from another surface would end up making a new photon. That theory fixes this perceived dilemma.
It goes through hole number 2. That seems very obvious that it can't do anything else if it's a lump. And I'm going to discuss this proposition, so I have to give it a name. I call it Proposition A.
So again, it's not a lump, it's a composite object. Even if you have a wave theory, you have to understand that more than one wave has to go through the slits to call it a photon, that has a certain length, a certain number of waves, a certain, to even detect the frequency, there has to be more than one blip, like a radio wave. It can't just be dot. There, that's my radio wave, dot. It has to be dot, dot, dot. It has to be a sequence of events.
Now, we've already discussed a little bit what happened with Proposition A. If it were true that an electron either goes through hole number 1 or it goes through hole number 2, then the total number which arrived here would have to be analyzable as the sum of 2 contributions. The total number which arrived here will be the number that come here via hole 1 plus the number that come via hole 2.
Right, and what we know works is recognizing that there's not 2 holes, there's 4 surfaces. And if you use those 4 surfaces, you can explain why the pattern is more complex in the double slit experiment. So it's completely, their math is completely dependent on recognizing that it can't just be about hole 1 and hole 2. It's about the 2 surfaces plus the 2 surfaces. There's 4 surfaces, so you have to think about 4 vectors, 4 sources. So the 4 source math works, the 2 source math fails. Fact. Absolute fact. Unreasonably deniable fact.
And since this curve cannot easily be analyzed as a sum of 2 pieces in such a nice manner, and since the experiments which determine how many would have arrived, if only hole number 1 were open, don't give the result that this number is the sum of these 2, it is obvious that we should conclude that this proposition is false. It is not true that the electron either comes through hole number 1 or hole number 2. Maybe it divides itself in half temporarily and so on.
Right, maybe it does something wacky and silly instead of just some a more sensible recognition that some photons go straight through and are unobstructed, and the other photons, the ones hitting the surface, are the ones that become the fringe pattern. And those are composite photons, and they're made of bits, and the bits go scattering about, and the law of averages says you can put half of that scatter back together into photons.
So proposition A is false. That's logic. Unfortunately, or otherwise.
See, I mean, part of this could be all proven and dispensed with simple experiments, right? You could just take the single slit experiments, the slit openings, and you could say, how much light when there's no slits open? Okay, no light. Then I open one slit. What's the intensity of the light? I close that slit, open the other slit. What's the intensity of the light? Then I open both the slits and measure the intensity. And they'll find that the intensity is 4 times greater with both slits open than any individual slit open. And that'll just scream to you, obviously we can't make photons. The slit experiment can't generate new energy. So obviously, when a single slit was open, there was more energy going in that came out. We aren't seeing all the light that went into the slits because some of it has somehow been converted into something we can't see. More light went in than came out with a single slit. That's the only rational conclusion. The slits can't make photons. They can't make new energy. They can't produce more energy. So how come you have 4 times more photons when the 2 slits are open? And the only rational explanation is that obviously when one slit is open, I'm not seeing half the photons.
Right? We can test logic by experiment. And so we just have to do to find out whether it's true or not that the electrons come through hole 1 and hole 2.
It really won't be 4 times greater, right? Because we're only talking about 4 times greater of the fringe pattern. So only the fringe pattern part, the part that isn't the center, is going to get 4 times brighter.
Or maybe they go around through both holes and they split up and so. All we have to do is watch them.
So this is the part that's just so bad. Yeah, it'd be really great if we could watch photons, but yeah, we can't do that. So again, we can't do anything but analyze their poo. We can only analyze what they do when they die. Okay, we can analyze their corpses. We can't analyze them as living, free, floating objects. Can't be done.
We need light. So we put back here behind the holes a source of light. Very intense light. Light is scattered by electrons. It is bounced off electrons. And in other words, you can see electrons if they go by if the light's strong enough.
All right, now, this is just talk. I mean, it just doesn't make much sense to say, yes, it's scattered, but you can only scatter it off of a bunch of electrons. You can't scatter it off a single electron. You don't have any hope of seeing a single electron using light. So it's meaningless. I mean, it doesn't, it's just not a rational thing to say that we can see electrons when their electrons are moved and changed in their position by the act of being hit by a photon. That's fundamental to quantum electrodynamics, the subject he founded. So, I mean, how can he say this with any credibility at all? I mean, this is just a thought experiment. This isn't anything to do with a real experiment, that they have real evidence that this is how it turns out. And so this is just another gigantic, catastrophic flaw in this analysis, and I don't know why it doesn't bother people who care about facts and science. Science shouldn't be based on, implying an experiment was done that was never done. I mean, that's bad science, not good science. I mean, it's just a fraud.
So we stand back here and we look to see whether we see when the electron is counted here, a flash, you'll have seen the moment before the electron is counted here, a flash behind hole 1 or a flash behind hole 2, or maybe a sort of a half flash in each place at the same time. Because we're going to find out now how it goes.
Again, you won't have any fringes, you won't have any pattern if you don't have 2 sources in even a single slit. If both sources don't have a photon going by them, if both surfaces don't have a photon going by them at the same time, you're not going to see anything. There won't be any fringes. There won't be any photons. They won't reconstruct. It's a fact.
Oh, by looking. Well, you turn on the light and look. And lo, you discover that you see flashes behind either one hole or the other hole every time you get a count here.
Right, so he's really describing this as if it's an actual experiment they actually did, and obviously they didn't do it. If they did try it, it obviously wouldn't work, because how could you tell whether the photon went by the surface close to you or the surface away from you? Even if it's a single slit, you still can't do it because in the double slit you got 4 surfaces to worry about. But if you're trying to analyze one of those openings, you have to analyze it by understanding that, well, there's 2 surfaces.
Every time there's a count here, you see a flash behind number 1 or behind number 2. What you see is that the electron comes 100% complete through hole 1 or through hole 2.
Right, so just remember, the only way you can have a pattern is the 4 sources have to combine their pieces to the product. So there's no way it would be even possible for there to be less than 4 photons in the experiment for you to get the double slit experiment. It has to keep throwing photons at those surfaces continuously, or you won't get any pattern at all. But you won't be able to draw those vectors.
When you look, kind of a paradox. Well, let's squeeze nature into some kind of a difficulty here.
Yeah, so squeezing it with a bunch of fake notions of reality. So fake experiments they never did, with outcomes they made up, and that, again, is what we're supposed to include as a fact in figuring out the truth. So it's like somebody saying, we did an experiment and, we measured a gremlin, because he has mass, and he tipped a scale, and so we know there's gremlins because they have mass, they weigh a certain amount.
I show you what we're going to do, see? We're going to keep the light on, we're going to watch. And we're going to count how many electrons come through. And we're going to make 2 columns.
So he made a whole big hunk of this lecture was this silly little gimmick and playing this little fake game that we could count either photons or electrons when we can do neither one. And to prove, like I said, something that can't, that just is made up. It's not a fact. It's not a fact that there's only one photon going through one slit at a time. It's just not a fact.
I'll watch the holes very carefully while you please count how many are arriving in the detector. All right, you say, 1 arrived. I said, I saw that when it went through hole number 1. So we put here 2 columns, which is column 1 for number 1 hole and number 2 hole. And every time you get one, you tell me about what I have seen it, of course. And I say either number 1 or 2. The first one was 1. What's the next one? Number 2. All right. Number 2. Number 2. Number 1. So as we watch the electrons, as I watch the electrons, for every one that you count, I can separate them experimentally into 2 columns. And them are what have arrived via hole 1, and those, I know the English is right, I'm just trying, that arrived via hole 2.
Right. So if they actually did do this, where they could actually have photons isolated and they would only go through one slit or the other slit, or electrons one slit or the other slit, the argument would be there wouldn't be any pattern. Now electrons are a little bit different because I don't think it has any, electrons aren't composite objects. You don't need more than one of them to go to the target. They can't split into pieces. So the pattern's being created by a completely different cause. And the fact is the pattern isn't the same as the light pattern. It isn't the same shape, the same form, the same proportions. So it does indicate some other cause possible, probable.
So the total number that arrived, well, first, what does this column look like when you add it all together for different positions here, which is just the number that is supposed to come through 1. I watch behind 1, and what do I see? I see this curve. That column is distributed this way. Just like we thought when we closed hole 2.
All right, so again, it was never done. It never did have that outcome. If you did attempt detecting, you would end up skewing that curve all over the place. You'd make a mess of it. As he stated, you're going to scatter photons off of electrons. That means the electrons get scattered also. So you're going to completely change the pattern. Yes, maybe you won't get the traditional interference pattern, but you're going to get some kind of pattern because you're going to mess up the original pattern. For certain.
Same way, whether we're looking or not, if we close hole 2, there's the same distribution. Here, you notice it arrived as if we are watching. And likewise, the number in this column that is supposed to arrive via hole number 2 is also the simple curve. Now look, the total number which arrived has to be the total number. I just counting little marks. It has to be the sum of this number plus that number.
Well, we already know it isn't. So again, the whole point is that we know it isn't. Okay, that somehow 2 slits makes more light than 1 slit. That 1 slit plus 1 slit equals 4 slits worth of light. Or some measure more. Like I said, it's really about the fringes. The fringes are the only parts that are recreating photons. So they're the only part where this effect is going to take place in terms of the fact that you have more sources, you have more capacity to recreate the pattern.
The total number which arrives absolutely has to be the sum of these two. It has to be distributed this way. When I said it was distributed this way, it's distributed this way. It really is, but it has to be. It is. It's distributed this way.
Yeah, so again, they never did the experiment. Of course, it wouldn't be distributed that way because the slits are so infinitesimally close together with electrons. Electrons have a higher frequency, technically, quote unquote, right? Their fake frequency number. They have a much higher frequency than visible light. So they're even closer than 1 millimeter apart. They're like a hundredth of a millimeter, a thousandth or a millionth of a millimeter apart. So clearly these two humps would be in exactly the same place.
If then we mark with a prime the results when a light is lit, prime means with a light lit, then we find N1 prime is practically the same as N1 without the light, and N2 prime is almost the same as N2. But the number that we see when the light is on is equal to the number that we see through 1 plus the number that we see through 2. This is the result that we get when the light...
So again, it's all just a thought experiment, never done in real life, just made up, all made up. Made up physics, made up science.
Light is on. In other words, we get a different answer whether I turn on the light or not. If I have the light turned on, this is the distribution which you measure over here.
No, it isn't. Not measured. Certainly wouldn't be that distribution.
If I turn off the light, this is the distribution that you measure over here.
Yeah. Again, nonsense.
Turn on the light, this is the answer. Turn off the light, that's the answer. See, they just squeezed out.
So again, clearly he stated as if this is a real experiment, they really did it, this is really what happens, and none of that ever happened. It's all just fake.
We could say then that the light affects the result. If the light is on, you get a different answer than if the light is off. If you want to, you can say the light affects, it does affect. In fact, we found this by this experiment, we get a difference with the light on and off. Light affects the behavior of electrons.
Right, so he just said it. We found it by doing this experiment. Nobody's done this experiment.
If you want to talk about the motion of the electrons through here, which is a little inaccurate, you can say that the light affects the motion, so that those which might have arrived at the maximum are somehow been deviated or kicked by the light. And
somehow, I mean, he's talking like we wouldn't have that as a direct expectation, that you could never hit an electron with a photon and expect it not to be moved. So you're obviously changing its momentum by interacting with it. You can't avoid that. So again, that's basic physics. That's well settled physics. There's no case where you could hit an electron with a photon and have any expectation the electron will continue doing what it was doing. It's going to be doing something completely different.
Arrive at the minimum instead, so smoothing the curve to produce this thing. You see, electrons are very delicate. Although when you're looking at a baseball and you shine light on it, it doesn't make any difference, the baseball goes the same way. Electrons are very flimsy, very delicate. And when you shine a light on it, a little tough on the electron, it knocks them about a bit, and instead of doing that, they do this, because you turn the light on.
So again, he's made that part up, because they wouldn't do that, right? They wouldn't do their original pattern if you've just disturbed them radically with a bunch of hitting them with photons. They obviously wouldn't make the same pattern as they would make with the light off. Come on.
Strong. You hit them with a hammer. It's not just a delicate thing like when you're looking at a baseball with light. They are hitting with a hammer. But you usually turn up the light too strong. Turn it weaker and weaker and weaker until it's very dim. And then use very careful detectors.
Well, you know, that isn't going to work either. But that's part of the thing that proves this thing isn't a wave, is that you can't make it into some small wave. It's a clump. It's momentum. And it hits it as a whole photon. So it really doesn't matter. You can count how many times you miss it, but when you hit it, you hit it. It's always a home run. It's not, you know, there's nothing else.
You can see very dim light. And look, with the dim light, as the light gets dimmer and dimmer, you can't expect with very, very, very weak light to affect the electron so completely as to change the pattern 100% from this pattern to this pattern. As the light gets weaker and weaker and weaker, somehow it should get more and more like no light at all. And how then does this turn into that? Well, it turns out that light is not like a wave of water, but light also comes in particle-like character called photon. And as you turn down the intensity...
So I understand the word photon is the real problem here, because photon is implying that, like an electron, it's an individual discrete object, when clearly, I think, obviously, I think the preponderance of the evidence points to the fact that a photon is a sequence of events. It's more than one thing. It's made out of more than one component. There's no frequency without the components.
Intensity of the light, you're not turning down the effect, you're turning down the number of photon particle-like things that are coming out of the source. So as I turn down the light, I'm getting fewer and fewer photons. The least I can scatter from an electron is one photon, and if I have too few photons, well, sometimes the electron will get through, and it just happened there wasn't enough light, there was no photon coming by, I didn't see it. So a very weak light doesn't mean a small disturbance, it just means a few photons. And what happens is that I have to invent a third column. You see, you get a click over here, I say, I saw that one, that was in number 1 hole, this was behind hole number 2, then another contact, I'm sorry, I didn't see that. There wasn't enough light to give a photon at that time, so there must be a third column under didn't see. And when the light is very...
So again, there's just no way you could do this. There's no way you can see the shadow or any indication of a single electron. You could never detect whether a single electron went past. It's just a nonsense, made-up story.
Strong, there are very few in there. When the light is very weak, most of them end in there. So that there are 3 columns, this one, and sometimes in here. Right, and guess what happens? The ones I do see are distributed this way. The ones I didn't see are distributed that way.
Right. Never happened. Just never happened. Obviously, you could degrade the what you're getting by doing anything to break the pattern, break the capacity of the photons to be regenerated into a pattern. The same with the electrons. So you could create some disturbance in the experiment to force more electrons to hit the surface or bang into the surface or something, wobble the machine, do something. Obviously those things will all affect the pattern. You get less pattern. It doesn't mean anything.
And as I turn the light weaker and weaker, well, I see less and less of them. The greater and greater fraction are not seen, and the actual curve in any case is a sum of a mixture of this and this, and as the light gets weaker, so that fewer and fewer are seen, it gets more and more like that in a continuous fashion.
So again, the electrons don't produce the envelope pattern. They don't produce a double slit pattern that has the traditional, it's on in the middle and then it stops and then it goes, the pattern reemerges and then stops and then it reemerges. So it doesn't have that quality to it. It doesn't have a traditional 2-slit pattern.
In this case, if the electrons are not seen and nothing bounced off the light under those circumstances, you get this complicated pattern for those electrons which were not seen. The ones in the column didn't see are exactly distributed in this complicated way, and the other 2 columns are in these 2 ways here.
So again, it doesn't have an experiment that proves this at all, so blah, blah, blah.
Now, you say, I got another way to measure which hole it goes through, and I'm sorry I haven't got enough time to discuss a large number of different inventions that you might have to find out which hole the electron went through. And
so again, they're still saying, let's figure out what hole the electron went through, instead of saying, well, we know this is about surfaces. That's the only logical conclusion. So why don't we talk about, figuring out what surface, caused the effect, and whether all 4 surfaces, again, for the math to work, all 4 surfaces have to make a contribution. If all 4 surfaces don't make a contribution, you're not going to get the double slit pattern.
What happens in each case? It always turns out, however, that it's impossible to arrange the light in any way so that you can tell through which hole the thing is going without disturbing the pattern of arrival of the electrons from this form to this form, without destroying the interference. And
again, you're not destroying the interference, you're changing the momentum of the electron. You're changing where it's going by interfering with it. That's the interference. The interference is your detector. Ugh.
Not only light, but anything else. You use neutrinos, you use anything.
Okay, so again, he just makes it clear that this is all made up. Okay, because obviously never did a neutrino experiment. He's just making this proclamation that this is true for everything. Cats, dogs, bananas, it doesn't matter. Everything does this.
Principle, it's impossible to do it. You can, if you want, invent a way to tell which hole the electron's going through. Then it turns out it's going through one or the other. But if you try to make that instrument so that at the same time it doesn't...
See, you really could do this experiment with elephants. And you could just have a rule that when the elephant goes by the surface, the elephant changes its path, right? So the elephants are taught, they have to go straight through. If they go near the surface, you could just say, okay, you go, now you're going to get varied. And so we just randomly change the direction you're going. And then we just put the elephants in with, head to tail, with a certain amount of distance between them, a frequency of elephants. And you put the frequency of elephants into the experiment. And the fact is, you can create exactly the same phenomenon in the sense that the elephants are scattered. They're knocked out of perfect sequence. They travel different path lengths, and the fact is a mile away you can collect the elephants at different locations, and some locations they'll be back in the correct order, they'll be back in the correct distance from each other, and in other locations none of them will be back in the right distance from each other. So you can make a simple mechanical description of the outcome by just recognizing that the slits are the only thing creating the phenomenon, and that it's really simple thing that's happening. They're just, the elephants are in a pattern, you're breaking the pattern, and you remake the pattern by having the elephants travel different distances. And by having them travel a full wavelength of a difference in distance will mean nothing. It'll mean like you didn't break it at all. But if it's less than a full wavelength, then you did break it.
Disturb the motion of the electron, then what happens is you get back. You can't tell anymore which one it goes through, and you get this. If you can't tell, you get this. Heisenberg noticed when he discovered the laws of quantum mechanics that the new laws of nature that he discovered could only...
So, just terrible. Heisenberg's the bad guy, Schrodinger the good guy. It's just so bad, this wooey nonsense that there's some law that we can't see. When we know the only stuff that, all this uncertainty only exists in the things too small for us to see. All of these magic powers, all of these wacky rules only apply to things we can't see, too small to see. So it's just a coincidence that all the wacky stuff exists in the very place we can't see. So there's a door we can't look behind. Right, we open every other door and it has all this normal crap in it. And the argument is no, all the ghosts and goblins and hobgoblins, all the bullshit is in the door we're not allowed to open. Just happens that way. The magic of the universe. Just a coincidence.
Be consistent. If there was some basic limitation to our experimental abilities that had not been previously recognized.
Yeah, there is this huge limitation, so that's the concession. And we can recognize it. It's right in our face saying, oh yeah, really, really tiny stuff you can't see because you can't bounce anything off of it to see it. You can't interact with it without affecting it, of course. Very small things can't be interacted with. Just a fact.
In other words, you can't experimentally be as delicate as you wish. And he proposes uncertainty principle, which stated in terms of our experiment is the following. He stated it another way, but they're exactly equivalent. You can get from one to the other, but unfortunately I haven't time to explain that. But in our experiment, his uncertainty principle would be stated in this manner. It is impossible to design any apparatus whatsoever to determine which hole the electron passes, and we want to succeed in determining which hole...
Yeah, well, all you have to do is say there's no way to devise any device that can measure something that's smaller than the smallest ruler. We can make a ruler a certain size, and that's it. We can't make it any smaller. We don't have anything smaller to make it out of. But there are things smaller than the ruler because we made the ruler out of those things. So there's pieces too small to measure. Just a fact. Doesn't mean anything.
The electron passes, through which hole the electron, which can determine through which hole the electron passes. That will not at the same time disturb the electron enough to destroy the interference pattern.
That's the simple answer. And instead, Heisenberg's answer is that, no, the wackiness is built in. It's not a matter of just disturbing. It's a matter of, if you did know, it would be wacky anyway.
And no one has found a way around this. And I'm sure you're all itching with inventions as to methods of detecting which hole the electron went through.
I don't think anybody be damn itching to do that, because it's just, you can pretty obviously understand the simple principle that, yeah, what am I going to make my ruler out of? I don't have any material I can make it out of that's going to be as small as the material I made it out of.
Each one of them is analyzed carefully. You'll find out there's something the matter with it, and that if, without disturbing the electron, you think you could do it. But it turns out there's always something the matter, and you can account for the difference in the patterns due to the disturbance of the instruments used to determine through which hole the electron comes.
Right, so that was a really poor description of Heisenberg, because really Heisenberg's not saying that. He's saying it's intrinsic. It has nothing to do with the fact that you're disturbing it. It has to do with the fact that you're not allowed to know.
Now, this, therefore, is a basic characteristic of nature and tells us something about everything. If a new particle is found tomorrow, the kaon, actually it's already been found, something, give it a name, let's say a kaon. And I use kaons to interact with electrons to determine which hole the electron is going to. I already know ahead of time, I hope, enough about...
Yeah, well, we already know that you're not going to invent any particle, okay? You're just not going to get something more minute than the elements of a photon. So again, this whole argument is moot.
The behavior of the kaon to say that it cannot be of such a type that I could tell through which hole the electron would go without at the same time...
Even if they're, like I said, I'd say the whole thing's made out of the same stuff, and the smallest version of it would be the elements of gravity. And again, even that's too much. That moves electrons. So you just can't... There's nothing to bounce off electrons. There just isn't anything that doesn't screw them up.
Producing a disturbance on the electron to change the pattern from here to here. So that that uncertainty principle is used as a general principle to guess ahead at many of the characteristics of unknown objects. They are limited in their character. Well then, let's go back. What about this proposition A? Does it go either through one over the other or not? Well, physicists have a convention, a way of avoiding the pitfalls which exist, and they make their game, their rules of thinking as follows. That if you have an apparatus which is capable of telling which hole the electron goes through, and you can have such apparati, then one can say that it either goes through one hole or the other. And it does. When you look, it always is going through one hole or the other. When you look...
All right, so again, this when you look. When you terminate it from continuing in its journey, it's only like if you see a laser beam, you're not seeing photons that actually go to the target. You're seeing photons that will fail to succeed to be part of the beam anymore. They're not photons in the laser beam anymore.
Look. But when you do not try to determine, or you have no disturbance, no apparatus there to determine through which hole the thing goes, under those circumstances, you cannot say that it either goes through one hole or the other. You can only say it, provided you stop thinking immediately and don't make any deductions from it. We prefer not to say it, rather than to stop thinking at the moment. In other words, when we don't look, we can't say through which hole it's going.
So again, this paradox is only created because they've narrowed their possible descriptions of what a photon is. So by saying it has to be this single object, it's not a pattern, it's not made of a combination of events, it's all, by doing all of that, they've made it impossible to explain the experiment. And it's only because they've narrowed the range of possible explanation.
But if you try to look to see, you find it always goes through one hole or the other. Still, to conclude that it goes either through one hole or the other when you're not looking is to produce an error in prediction. And
I mean, the obvious, you look at the slits and what are you saying? I mean, the obvious point is what happens to the photons that crash into the surface or just miss the surface or go really close to the surface? Wouldn't that be the obvious conclusion, is to say surfaces are going to screw up photons? Just as they would screw you up?
that is the logical tightrope on which we have to walk if we wish to interpret nature. This proposition that I'm talking about is more general. It's not just for two holes. It's a general proposition reads something like this, that the probability of any event in an ideal experiment, that just means that when everything is specified as well as it can be.
Yeah, so when you know all the variables.
The probability of an event is the square of something, which I call A here, is called the probability amplitude. And when an event can occur in several alternative ways, the probability amplitude is A number, is the sum of the A's for each of the various alternatives.
Yeah, so duh. So you figure out how, you do something, you're rolling dice, and you figure out that 7 comes up more than any other number, or 11. I don't know whether they're tied or not. But anyway, you find out that there's pattern, okay, that some number, a complete number made of 2 dice, comes up with a certain more probability. and you write these things down. You find out that, well, boxcar same as snake eyes, that kind of thing. Um, and and so you say all of it has to equal 100%. Like, you can never roll the dice and they don't come up anything. The faces disappear or something. No, that doesn't happen.
And finally, if an experiment is performed which is capable of determining which alternative is taken, the probability of the event is the sum of the probabilities for each alternative. That is, you're losing interference. Now, the question is, how does it really work? What machinery is actually producing this thing? Well, nobody knows any machinery. Nobody can give you a deeper explanation of this phenomenon than I have given. That is a description of it.
Yes, somebody can, and they can not include fake experiments never conducted, and they don't have to do all that stuff, and they can just recognize that the single slit pattern is different than the double slit pattern, and it's different for reasons, and you can figure out the reasons, and you can deduce it, and then you can figure out that two sources doesn't work, and that you have to recognize that it's about the surfaces, and so you have the two surface experiment, and then you have the four surface experiment, and so if you can go a lot better, whether it's deeper or not. You can think with a more open mind in terms of being more open to different understandings of what the mechanical system is made out of. Again, they're forcing photons to be bullets, not bullets fired at a frequency. All kinds of things they've left out.
They can give you a wider explanation in the sense that they can do more examples to show how it's impossible to tell which hole it goes through and at the same time not destroy the interference pattern. They can give...
Like I say, and they could give you the simple experiment where you just say, let's do it with people, and we just have a rule that the people who go next to the surface, are scattered. And I could do it with anything, and I could just point out that this little simple mechanical explanation saying, if you go near the surface, your pattern gets broken, and you can remake the pattern at a distance.
A wider class of experiments than just the two-slit interference experiment and so on, but it's just repeating the same thing to drive it in. It's not any deeper, it's only wider. The mathematics can be made more precise. You can mention that they're complex numbers instead of real numbers and a couple of other...
Yeah, and you can do a lot of other bad things to do, which is to say photons are the same as electrons, are the same as buckyballs, are the same as wildebeest, and they're all not the same. They're very different. They have different properties. They have different behaviors. It's just wrong to say they're all the same thing, and they do the same thing, because they won't do the same thing unless you force them to do the same thing.
Minor points which have nothing to do with the main idea, and the deep mystery is what I described. And no one can go any deeper today, but only wider.
Yeah, well, like I said, they could have done all of this 100 years before Feynman, 150 years before he says all this crap. They should have known already that two waves don't work. It doesn't create the right pattern. And this is the fact.
Now, I mentioned probabilities in this calculation. What we're calculating here, this curve, is the probability of arrival of an electron. The question is there any way to determine where it really arrives? We are not averse to...
Yeah, we didn't have a problem detecting where it arrives. We have a problem in analyzing why it arrives there. So, again, change goalpost.
Using the theory of probability, that is calculating odds. When a situation is very complicated, you throw up a die and it spins so many times in the air with the various resistance and atoms and all this complicated business that we're perfectly willing to allow that we don't know enough details, and so we calculate the odds that the thing...
Right. And so he's going to claim that we do know enough details about this mechanically to say it has to be magic. Yeah, so we don't say it's magic for dice, but somehow it is magic for photons and electrons.
It'll come this way or that way. But here, what we're proposing, is it not, is that there be probability all the way back at the fundamental laws. That in the fundamental laws of physics, there are odds.
Right, so he's saying it's not cause and effect. There's no cause. Going by the surface doesn't mean anything. Going through the middle of the slit doesn't mean anything. It's somehow just the fact that it's traveling between these two surfaces means it has to do something wacky. And it's not doing something wacky because of any electrical potential or any force or any physical mechanism, not even bent space. No, there's no physical mechanism. It's just some sort of stupid thing that says now everything changes and everything's superimposed and everything's not being measured for the whole distance to the surface. Nothing's being measured. Nothing's being no wave function is being collapsed. I mean, it's just too silly. And I really shouldn't have to say these words. It's too silly. I shouldn't be the only person saying it. Other people with a brain and reasoning skills should be able to say, that's too silly an explanation.
For example, suppose that I have an experiment so set up that with the light out, I get this interference situation and know that. Then I say that with the light on, I can't predict through which hole it will go. I only know that each time I look, it'll be one hole or the other. But there is no way to predict ahead of time through which hole it goes. The future, in other words, is unpredictable.
So again, he's emphasizing the point that he's not really saying there's any mechanical explanation, that there really is a magical universe that just makes electrons go to some place they weren't going. They're heading for some place and they somehow go someplace else, and they don't do it because anything physically changes their path. They do it because the universe decides we have to screw things up for no rational reason.
It is impossible to predict in any way from any information ahead of time through which the thing will go, or which hole it will be seen behind. That means that physics is kind of given up if the original purpose was, and everybody thought it was, to know enough that it
So everybody thought it was. Everybody thought the purpose of physics was to, like evolution, provide an explanation for the physical universe and what we see. And no, it's not the purpose. The purpose isn't to explain it. The purpose is to mystify it and create a much more interesting story of, a phantasmagorical, silly universe. Not anything that you could understand or make sense out of. No, it's all just helter-skelterly bullshit.
In a situation, you can predict what's going to happen next. Given the circumstances, you can predict what happens. Given the circumstances, source, strong light source, tell me which hole, behind which hole will I see the electron? You say, well, the reason you can't tell through which hole you're going to see the electron is it's determined by some very complicated things back here. If I knew enough about that...
So we already did this a few times, but we'll do it again, right? So again, they can see that they're shooting photons, and they're shooting them like with the machine gun, randomly in different directions. So we know the source doesn't have a standard direction that it produces photons at. But what if we made such a source?
Electron, it has internal wheels, internal gears, and so forth. That the fact, and that this is what determines through which hole it goes. So it's 50-50 probability because, like a die, it's set sort of at random. And that if I were to have studied it carefully enough, your physics is incomplete. If you get a complete enough physics, then you'll be able to predict through which hole it goes. That's the hidden variable theory, so forth.
Yeah, well, it's kind of a silly way to describe it as a hidden variable. It's just a hidden mechanics, the unseen mechanics. And the fact is that photons do leave point A, and they do head in a standard direction, and some of them will leave and they're going to head right for the surface, and some are going to head right from the middle, and those two photons will have a different destiny. One of them will be deconstructed and then reconstructed, and one of them won't have any problems at all and just end up in the middle.
Well, that's not possible. It is not due to a lack of detailed knowledge that we cannot make the prediction, because I said that if I didn't turn on the light, I should get this interference pattern. If I have a circumstance in which I get that interference pattern, then it is impossible to analyze it in terms of saying it goes through here or here. Because that current is so simple, mathematically a different thing than the contribution.
So again, it's still this stupid notion that they're forcing the photon to be, a complete object that can't, and it's not a pattern, and you can't break the pattern and remake the pattern. So as long as they're excluding the truth. They're basically saying the truth can't be the answer. The reasonable understanding of what a photon is does answer the questions. They're excluding that from one of the possibilities, and therefore saying it's impossible, because I've excluded the thing that's the rational possibility, that the surfaces are causing an effect, and the effect is that it's breaking the photon, and you can remake the photons it broke.
Of this and this has probability. So if it were possible for you to have determined through which hole it was going to go if I had the light on, The fact that I have the light on has got anything to do with it. Whatever gears there are back here that you observed, which permitted you to tell me whether it was going to go through one or two, you could have observed if I had the light off. And therefore you could have told me with the light off what hole.
See, if we could make laser beams that were in phase, that is, they were all sending photons at exactly the same rate, the same pattern, and we could have 4 different laser beams and point them all at the 4 surfaces, I would argue we could reconstruct the pattern with 4 independent sources where we knew exactly which beam was going by which slit. But the problem is we can't create light. We can't create 2 different sources of light that retain their phase. Or, yeah, I mean, that's the key ingredient. And beam splitters intrinsically disrupt phase, so that's why they don't work.
Each time an electron goes, which hole it's going to go through. But if you can do this, then that curve would have to be represented as the sum of those that go through there and those that go through there, and it ain't. And therefore,
yes, it isn't the sum of that, because it's the contribution of 2 surfaces and the contribution of 2 more surfaces, and you magnify the capacity to reconstruct a photon by creating another contribution. It's, you're adding 1 surface to 3 surfaces, so to speak. Obviously, that one surface creates a contribution with the surface 2. It creates a contribution with surface 3 and a contribution with surface 4. So it's not just plus 1.
Possible to have information ahead of time as to which hole it's going to go through when the light is out, or when the light is on, or out, in a circumstance where the experiment is set up there to produce this interference. So it is not a lack of unknown gears.
So again, he's saying it as if they've proven that, and they obviously, it's very hard to prove that. That would be a high burden of proof, and they haven't come anywhere close to proving it, and they just want to believe it, and that's why they say it. But it really hasn't been demonstrated that there is no way you could design the experiment to reveal the fact that it's just a mechanical consequence.
Of internal complications that makes nature have probability in it. It seems to be in some sense intrinsic. Someone has said it this way: nature herself doesn't know.
Somebody who? Who said that? Your daughter? I mean, somebody, a puppet you have that says exactly what you tell it to say? What the hell is that?
Which way the electron is going to go. A philosopher once said, "It is necessary for the very existence of science."
So he's mocking, this fundamental notion of cause and effect. He's mocking cause and effect as a rule. And just basically saying it's silly for you to think that if you set up the same circumstances, if physically I can actually make the same exact circumstances, that I'll get the same result. So he's almost arguing that if I clone a human being, I won't clone a human being. I'm not going to get a clone, when we know we can get a really close clone. I mean, obviously some things get messed up because of radiation and different things, and it's broken, and it has some imperfections, but we know the imperfections are just that, errors. They're things that broke the process. So, cause and effect hasn't been destroyed by the 2-slit experiment. It's just, but that's what they want to do, okay? And I wouldn't have argued that's what they want to do, but this is so overt. It's been around now, this is a long time ago, 60, 70 years ago, this lecture was done. Well, whatever, 50. Yeah, it's more than that, 60. That's a long time to sit there and not recognize that this is just religion. The intent is to destroy any notions of a deterministic universe and, pretend that, anything's possible. This is just mothers telling their kids, you could be president someday.
That the same conditions always produce the same result. Well, they don't.
So he's saying that somewhere he proved that with this stupid experiment, with then this pitifully poor physical analysis. I mean, not getting basic geometry right. I mean, he couldn't get the geometry of the real experiment accurate in his drawing. He didn't represent it accurately. He clearly didn't represent electron experiments accurately. and yet he's declaring we proved it. And this is such a simple experiment, and you trust them. You trust these people with the more complex experiments. They can't tell you the truth about the simplest experiment, and you believe them, when they tell you what the truth is about some complex experiment.
Set up electrons in any way.
You trust them. I mean, again, he's made egregious, simple errors, and you trust him. Why? Why are you letting him fly the plane? Why are you letting him define reality when he did such a poor job of it?
Yeah, I mean, you set up the circumstance here in the same conditions every time, and you cannot predict behind which hole you'll see the electron. They don't, and yet the science goes on in spite of him, although the same conditions don't produce the same results. That makes us unhappy that we can't predict exactly what will happen.
So again, this is about predicting. It's not about predicting. It's about understanding. We want to understand what happens. I don't need to predict it. I don't care, okay, frankly, about predicting it. I'm not gambling with it. I don't need to fix the dice. I mean, even if I was going to Las Vegas, I wouldn't want to do it if it was all fixed. So what would be the point of it? But I'm just saying, I do want to understand. So understanding that when you roll dice, there has to be physical interactions. Physical things happen to the dice. And those physical things that happen to it are not being controlled by some random god. They're being controlled by how the dice are thrown and where the dice are thrown and what they mechanically go through. And the same is true for electrons and protons and photons and all the rest of the little bits in the universe. They are all traveling a fixed, solid destiny.
You can make a circumstance which is very dangerous and serious, and man must know and still can't predict. For instance, we could cook up, I know we're better not, but we could cook up a scheme by which we arrange photocells so that if it sees the electron, one electron is going to go through. If we see it behind hole number 1, we set off the atomic bomb and start World War III. If we go see it behind hole 2, we have just to make peace feelers and delay the war.
So I guess this is some version of Schrodinger's cat that's even more maniacal and silly. So, shit.
Then, the thing is that the future of man would then be dependent upon something which no amount of science can predict. Our world is the future is unpredictable.
Right, it's unpredictable. That's true, because we can't know enough, not because there's a random god screwing it up.
What is necessary for the very existence of science and so on?
I mean, we can predict everything. We can predict so much. And here they're claiming that all of that reality of our predictive power is somehow in jeopardy because of this nonsense.
And what the characteristics of nature are not to be determined by pompous preconditions. They are determined always by...
Yeah, who cared? Nobody had a precondition. I mean, no one said it's an absolute fact that the answer can't be some wooey factor. But the point is you have to prove the wooey factor. You have to show evidence of the wooey factor. You can't just argue for it. So they're just arguing for it. They're not explaining why it has to be that way, that it's the first choice of an explanation, that it's the only possible explanation. No, they didn't demonstrate any of that. And they certainly didn't do it with any kind of credibility, in the sense they can't even draw simple geometric figures accurately. They can't even admit after 150 years that Young's drawing doesn't produce the right pattern. I mean, this is 150 years after the Young experiment, and they fully knew by Feynman's time that the double slit pattern isn't a simple pattern.
The material with which we work, by nature herself,
it isn't that squiggly slop he drew. It isn't that generic or messy. It has a difference. The single slit pattern, this double slit pattern, distinctively different.
We see what we're going to find, what we find, and we cannot say ahead of time successfully what it's going to look like. The most reasonable possibilities turn out often not to be the situation. What is necessary for the very existence of science is just the ability to experiment, the honesty in reporting results.
There we go. So right there, you're just saying, gee, what a hypocrite. What an insane bit of duplicity. No honesty in describing the electron experiment. No honesty in describing what the geometry of the directions the stuff travels. No honesty in pointing out that the single slit makes it kind of obvious because most of the light goes straight through. It doesn't change at all. It doesn't do anything you wouldn't expect. Most of the light flies through the center and ends up as a bright spot in the middle, and only a fringe percentage, 10% of the light creates the fringes.
Must be reported without somebody saying what they like the results to have had been. And finally, an important thing is the intelligence to interpret the results, but important point about this.
Yeah, the intelligence to be careful and cautious, don't jump to conclusions, don't get too excited, don't do all of these things that they know that's what good science is made out of, is discipline and caution and careful. Redo the experiment, like the Eddington experiment, for example. Yeah, redo it before you start writing New York Times headlines.
Intelligence is that it should not be sure ahead of time about what must be.
So they again, forget it. You've made it clear that every time you see a pattern, you're going to jump to a conclusion. Every time you're going to do an experiment, you're going to have a bias built into it that it can't be anything else.
Now, it can be prejudiced and say that's very unlikely. I don't like that. Prejudice is different than absolute certainty. I don't mean absolute prejudice, just bias. But not strict bias, see, not complete prejudice. As long
as his prejudices are okay, your prejudices suck. That's all. This is just such gibberish.
Bias, it doesn't make any difference, because if the fact is true, there will be a perpetual accumulation of experiments.
Yes, you would think so, right? You would think they'd redo the Eddington experiment and find out it doesn't work, and then they do it from space with 400 times better resolution. Say, oh yeah, that shit is bullshit. Forget it. Okay, we don't need that anyway. Einstein should have never gone with this whole equivalence thing, because you don't really need it to do the relativity thing. So he should have never even said it in the first place, because it's just a gibberish. It's just a nonsense. Yeah. And the same is true with this experiment. Like I said, they didn't do any analysis.
Actually annoyed.
They didn't really look at it and really pick at it to say, okay, let's force this thing to give us the answer. And when they do it, like I said, they do it like Veritasium did it. He had the objective of showing you it working, and he forced it to happen. Okay, he broke the detecting device essentially to force the result.
Until they cannot be disregarded any longer. Only can be disregarded if you're absolutely sure ahead of time of some precondition that science has to have. In fact, it is necessary for the very existence of science that minds exist which do not allow that nature must satisfy some preconceived condition.
Right, and you're the one who now is imposing the precondition. It must be Heisenberg. There can't be any mechanical explanation. It has to be the Wooeyverse. So, and none of them, like I say, they won't fix any of it. They won't admit the flaws in this judgment. They won't miss the misdirection this experiment created. They won't admit any of it. They won't admit their physics is based on unrepeated experiments, that the experiments themselves are convoluted and complex and can be misunderstood. They won't admit that the evidence is just fundamentally weak, that it's nothing like the evidence for evolution, nothing like the evidence for other theories of mechanical function, that it isn't rigorous physics and rigorous science.
Like those of our philosophy.
So again, that's all he's doing here is philosophy. The experiments, the physics was garbage. He didn't even, like I said, couldn't even get basic, grammar school algebra right. All right. So it went on a bit, but this is a really, this really should be worthy of some interest and some conversation. The very fact that this experiment that's so fundamental, Nobel Prizes were won over it. These interpretations and these diagrams drawn, and they're wrong diagrams. They're mechanically unsound, and there should be some other smart person on this planet capable of admitting that this is a really, this is not good news for physics. That their foundation is this bad, that this much in misinterpretation and misdirection and distortion was part of and it was just a propaganda. It was just a story they told. It wasn't the truth. And they based a whole, like I said, the whole ideology is based on it. They wrote the whole Bible of physics on this nonsense. Oh, okay. Is it 10 o'clock? Oh, yeah, it is.
Yeah, I'm really sorry. Okay. Good. Just hang on the porch. I'll be right out. Okay, yeah.
let's see. Yeah, well, you'll just have to pretend there was a better ending than this, but I really don't want to try to cut it off. So, don't want to have to edit the video just to get rid of whatever the ending is. So anyway, till the next time and such, so forth and whatnot.